Hello everyone. So we are in chapter 9. In chapter 9 we're going to talk about hypothesis tests for one population mean. So previously we talked about confidence intervals. And with that we got into our inferential portion of the course, inferential statistics that is, that we would like to generalize to the population parameters now. So in chapter 8, we looked at point estimation, a single guess at the value of the parameter we want to estimate. And then we also stated our belief about the population mean in form of an interval, a confidence interval, we called it. Now in chapter 9, we're going to talk about another form of inference, and namely hypothesis tests. Now hypothesis tests are very prevalent in research, and they sit at the heart of any research. So we'll be able to, by the time we get through chapter 9, have a fairly decent understanding of what is a hypothesis and how do we go about testing it, what's the logic of it, and what is the mathematics behind it. Now let me forewarn you also that in chapter 9, some students think this is the most challenging chapter of the course. So you'll be the judge of that. Not because it's a hard chapter, it is not hard, but it's highly conceptual. Highly conceptual means it requires that you really think about what you're reading and really try to soak up as much of it as you can, because there are a lot of jargons, there are a lot of terminologies and definitions. In fact, you will see in this section we don't have any formulas. We'll spend about an hour of lecture talking about conceptual stuff. So if you get bored throughout this, please feel free to pause the lecture, take a break, a breather, and then come back and listen again. So with having said that, let's actually proceed with the idea of hypothesis testing. Chapter 9, we're going to cover 5 sections. There are 8 sections in chapter 9, but we only cover 5 sections of chapter 9, and these are the 5 sections. Section 1 deals with the nature of hypothesis testing, and that's what we're doing this time in section 9.1. Now, let me begin by stating what is actually a hypothesis here. So let me also arrange my note as I go through. Okay, so what I have is a definition of a hypothesis. Okay, and of course you can see the author has his own definition of a hypothesis. That's right up here, what a hypothesis is. Now, a hypothesis is simply a statement of belief. It is a statement we make. I've written down a conjecture or an assertion that you make about the values of the unknowns of the population, namely the parameters of the population. So that's all a hypothesis is. So for example, I just made a hypothetical statement. So this is my hypothesis. I believe that the average rent for a 1-bedroom apartment around San Diego Mesa College, I believe that's zip code is 92111. I think the 1-bedroom average rents for about $1,500 per month. Okay, that's the average monthly rent again. Okay, of these apartments per month. Okay, so there's my hypothesis. Now, you either could agree to my hypothesis or disagree to it. And then, of course, we'll talk about that later. How can you disagree? And then the process that unfolds. Now, here's another example. Now, notice my first example with the rent. I think that was a reasonable hypothesis I made. Not too many of you frowned on that. But look at my second example. This one, I don't think too many people will buy this hypothesis, huh? I think, on average, our community college students earn about roughly $120,000 per year. Now, that includes yourselves as you're reading or looking at this video. Now, I'm sure that may raise some eyebrows, right? Maybe that's not quite right, huh? But, hypotheses are like opinions. Pretty much, you could have your own hypothesis. Some people hypothesize that the average speed on the freeways are now approaching about 90 miles an hour. Now think about that. We're not talking about individual speeds. We're talking about the average speeds. When the average speed is 90 miles an hour, that's pretty horrendous. So, nevertheless, here are the examples. Now, as far as the structure of the hypothesis goes, every hypothesis has two statements or two parts, a null and an alternative. And again, up here, the author, you can see, he clearly defines his null and alternative hypotheses. Those are the two statements that I made every hypothesis must have. Okay, now, my definition of null and alternative, I'm not defining what the author is saying. It's just I'll try to give you alternative definitions that draw parallel to the author's. But yet I try to be maybe a little more complete and more thorough as I make these definitions. So the null hypothesis here, this is a hypothesis or the claim that you want to test. Now, the null hypothesis quite often is referred to as the status quo hypothesis. And being status quo, when things are status quo, you hear that a lot about government. In government, things are status quo, means they do not change. They pretty much behave or act or are run the way they have been for many years. So that's the idea of status quo. So being status quo, that means it often represents the hypothesis of no change or no difference in the values of the population parameter. Now, symbolically, we use H for hypothesis, the first letter in hypothesis, and then there is a subscript on H. Okay, and the subscript on H, it looks like a 0, but it's actually a null sign or null symbol. And what I have here is an example, like for example, in trigonometry, when you work with angles and triangles, you probably have seen this, like 30-degree angle. Even with temperature, like 30 degrees Fahrenheit. So that's what that symbol is. It's the null symbol, not a 0 symbol. But that's what we're going to use to represent that's part of the statement. And then every hypothesis must have what we call an alternative hypothesis, which quite commonly it's referred to as the research hypothesis. Okay, now this is the part that research actually tries to show or prove. And it tends to go the other direction as the null hypothesis, the status quo does. So the purpose of the alternative or research hypothesis is to show that there has been a change and that the status quo no longer holds. Okay. Now, as far as how we go about it again, what do you mean by change? Because we're talking about parameter values. The change could be higher, lower, or simply not what it used to be. Now, symbolically, I've put in some of these common notations for alternative hypothesis. The one your author uses is actually the one that is the first one. It is this one, H, with the lower subscript A. That's the alternative. Okay. Now, let me scroll, and one thing to note immediately is that the null and the statements of the null and alternative, these turn out to be complementary events actually that we will define. And being complementary means they have no common outcomes. So for example, if null says something is good, alternative says it's not good. Now you can say bad, but simply not good is the negation of the null. So it is at that level. So keep in mind that null and alternatives must be negations of each other, of one another. Okay, and what do we mean by a hypothesis test? When we talk about hypothesis test, which is what we are about to delve into, we're talking about a collection of procedures that ultimately help us decide whether we should stay with the status quo or whether we should reject the status quo. So that's what the hypothesis test is. Now, here I made up a couple of more examples. This is the first one. There's another one below it. Here's the statement of the null regarding a new vaccine. The status quo is that, well, there was no vaccine before this company, XYZ company, attempted to create one. So the null takes the natural side that the vaccine is not effective. And the alternative or the research, this would be perhaps the company that's made the vaccine, they would like to show that the new vaccine is effective. So this becomes their research hypothesis. Here's another one, the one that was ridiculous in nature. Again, excuse me. I made a hypothesis that the average community college makes $120,000 a year. So the null would be, well, they don't make $120,000 a year. Or actually, if you want, we can even, because there's some flexibility built into this. So let's say if I am the null now, I'm going to actually erase this part. Okay. Suppose I am the null. I'm the one that's status quo. I made the comment that the average community college student makes $120,000 a year. And the alternative to that would be that the average community college student, instead of makes here, let's make this does not. So let's say, see what I've done here, I switched. I made you the researcher and I made myself to be the status quo. So again, it depends on how we want to portray this research. That's how we can adjust the statement of the null and the alternative. So again, I become the null hypothesis here. I believe that the average student makes that much, and your position would be that the student does not make that. Now, you could have stated your disbelief by saying, I think it's less than actually. So you could show your disagreement in the form of does not make that amount, or you be more specific, you actually have a direction. You say it is less than. Now, in chapter 9, we are actually interested in testing the hypothesis that the mean is, we're going to test hypothesis about the mean of a random variable x in this work. Okay, so let me continue on here. Now, here I have the different forms of hypothesis. This is what our hypotheses are going to look like in chapter 9. The null hypothesis, these are 3 classifications of a statement of the null hypothesis. The first one reads, or the null hypothesis here says that mu is less than or equal to some value. The second one says the mean is equal to some value, and the other one says it's at least is greater than or equal to some value. Now, the mu with the subscript 0 is what we call the hypothesized value of the mean. Now, the alternative hypothesis here is going to be so the alternative hypothesis in the first case is going to be that the mean is greater than some hypothesized value. The middle one reads that it is simply not equal to, and the last one says that it is less than the hypothesized value. So this hypothesized value, for example, with my rent example, was $1,500. That's what mu sub 0 is, mu naught. And that's what they call this one, mu naught. And here's what the mu naught, I just said it. This is the spelling of the mu naught. That's what it is. Mu naught is N-A-U-G-H-T, mu naught. That's what this subscript is read. This is how that's read. Now, in terms of classifying the hypothesis, there are 3 classifications, and all 3 of these depend on the sign of the inequality on the alternative hypothesis. So if the alternative hypothesis is greater than, we refer to this as a right-tailed test. If the alternative does not equal to, that makes the test a two-tailed test, and if it's less than, it becomes a left-tailed test. Later on, it will become more obvious why it is stated that way and why are they classified or categorized as such. And what does this right-left two-tailed, what does the tail has to do with this? So we will investigate that later on. But one thing I want you to note here, by the way, is that if you look at the complement of greater than, that would be less than or equal. Complement of not equal is equal. and complement of less than would be greater than or equal to. So keep in mind that null and the alternative are complementary events. And also, one thing is that in your book, the author, by the way, he always chooses to show the null hypothesis, and let me write that. The null hypothesis, your author always, he takes it to be mu equals to some hypothesized value. And there you go. That's the position of the author. And the reason he does it, because he would like to keep it simple for the students, to keep it straight that it's always that. But the alternative has to be one of these. And anytime you test a hypothesis, you're doing one of these. Not all three of them, not 2 out of 3, just one of them, depending on the research that we want to do. So, question is that, well, how do we know when to use less than, greater than, or not equal to? And to help you out, I have these keywords. So, and these keywords, we read them in the statement of the problem as we do these homework problems. So you look for keywords such as any keyword that leads to an inequality, pretty much. At least, at most, so remember, at least would be greater than or equal to. At most would be less than or equal to. No difference means not equal to. No more, that means less than or equal to. Exceeds, again, that's greater than or equal to, and so on, however they stated. So those are the keywords you look for when you read these word problems, and that will lead into setting up the alternative. Oh, and one last thing before I move away from this is the following. If you note the alternative in all 3 cases, look at the inequality in all 3 cases. None of these 3 inequalities actually have an equal sign. So keep that in mind. That's going to help you quite a bit when you try to set up the statement of the alternative. Remember, the alternative cannot have equal sign in it. And by contrast, the null will always have equal sign in it. You see, all 3 cases, the null has some form of equality in there. Okay. Now, what's the logic of how we're going to do this? What's our logic? How are we going to go about doing this testing? Well, I guess the logic makes sense. The logic is logical in this case. So what we're going to end up doing is, well, what if we choose a random sample from wherever it is that we're talking about, this population that we are researching about. So let's choose a random sample from that population, and then we're going to come back and we're going to compare the sample results to the hypothesized value. So for example, when I say the average rent was $1,500, why don't we go out there actually in the 92111 zip code and get a sample of 1-bedroom apartments, and let's see how much average rent would be for those sampled values. That makes sense, doesn't it? And then we're going to compare the average from the sample to that of the population, or the hypothesized, I should say, value of the population, in that case, $1,500. So let's say you go get a sample, you come back, and your sample shows $1,200 a month. Then you have evidence that, well, perhaps my statement wasn't true, that it is indeed the average is less than $1,500. Or if you go out and get a sample of 1-bedroom apartment, the rents per month, and let's say your average shows $1,800 per month. Now you're going to come back and say, well, it seems as if the sample does not support your hypothesis. The sample average is actually higher than $1,500. So that's how we're going to go about doing this, the logic of it. And then, of course, the question is, how far away from 1,500 are we going to allow flexibility here? How much leeway is there away from $1,500? Is $1,550 close enough? Is $1,475 close enough? So those actually remain to be seen. We'll discuss those later on. Okay. Now, the question might be, well, what is our mathematical basis for this, right? Everything we do has to be mathematically sound. So the proof by contradiction is the mathematical engine behind the test of a hypothesis. Now, what is this proof by contradiction? Some of you probably know. For those who don't, I made a really simple example of proof by contradiction. So here in this example, I want to use proof by contradiction to show that 2 plus 1 equals 6. Now, that's not a typo. I know 2 plus 1 is 3, right? But I'm making a false statement. 2 plus 1 is 6. I want to show that that is an incorrect. I'm not saying that's a correct statement. I want to show that that is an incorrect statement using that proof method. So when you use proof by contradiction, you always assume the hypothesis of whatever that theorem or whatever that statement is true. So going forward with this, I'm going to say, well, okay, let's say it's true. 2 plus 1 is indeed 6. We're not saying it's wrong. Let's say it's true. Assume it's true. And then we're hoping to reach a contradiction, and hence the name proof by contradiction. So here's what I've done actually to keep it simple. So if I grab, let's say, 2 apples, and then I grab another apple, and I combine it, I should get 6 apples, don't I? So why is it that when I add 2 apples and another apple, I get 3 apples? That doesn't look like 6, does it? So I can say at this point that I have reached a contradiction. This contradicts our supposition, what we assume to be true. And that's a very basic idea of proof by contradiction. And that's how it is. So as far as the way it works with research now, the proof by contradiction in hypothesis test is this. We're going to get a sample value. That would be like getting my apples. We're going to get a sample. And then we come back. We're going to say, okay, we're going to assume what you say is true. The average community college student does make $120,000 a year. Sure, I'll buy that. So if I go to the population of community college students and get a sample, shouldn't I expect to see averages that are on or about $120,000 per year? So that would be our supposition. We say, yeah, sure. And then that's when we go out and get a sample, we come back, and then we compare and say, look, we presumed your statement was true, but the sample is not supporting that. Therefore, we have grounds for rejection, and we have arrived at a contradiction. So that's how it's going to work with us. Now, the other thing that's very interesting here is actually an example of proof by contradiction is what our judicial system is based on or based upon. In our judicial system, existing judicial system, the assumption, the null hypothesis here about the innocence or guilt of a defendant is that defendant is innocent until proven guilty, correct? That's the assumption of our judicial system. So our whole judicial system, in fact, the mathematical basis of our judicial system is based upon proof by contradiction. So, and remember, we always assume this statement be true, correct? That whoever walks into that courtroom, the defendant is innocent until proven guilty. So that's what this assumption is. Now, it may be a faulty assumption, but that's fine. That's the whole basis or premise of this proof. There's nothing wrong with this. Now, the alternative, of course, is the negation or complement of that statement, that the defendant is indeed guilty. And as we know, it is up to the prosecution, right? The prosecution has to actually gather evidence. They have the burden of proof, don't they? The defendant's just going to sit in the room. That would be like me. I made a statement. If you don't believe what I'm saying, that students make $120,000 a year, why don't you go and get your sample? So that's pretty much how this works with our judicial system. The prosecution has to gather evidence against the null. Now, what I have here actually is down below, I have a table, a 2x2 table, 2 rows, 2 columns. And the label of this table, I have the true state of nature about the null hypothesis. What do I mean by true state of nature? The true state of nature means what things truly are the way they are and nobody knows. So for example, think about a defendant, total stranger sitting in a courtroom. That stranger, no one knows if that person is really guilty or innocent. but the defendant himself or herself know that are they truly innocent or guilty. Agree? So that's what that is. The true state of nature is what truthful is about the null hypothesis, what it truly is. So let's say the true state of nature about the null is that the null is true. In our judicial system, the true state means this. This person who's sitting in the defendant seat is truly innocent. That's what that means. The column next to that is false. So that means the person who's sitting there, he or she knows they're guilty. They're just being silent. They're being quiet about it. But they know truly they are guilty. It's just now we got to go through this process. Now, to the left, I have decision. So this is, think of it as the jury comes out and renders a decision. So that's what the decision is regarding the null. And suppose there's no hung jury here, okay? So the decision is actually pretty clear cut. And the decision is either to reject the null or accept the null. Okay, let's say those are our only two choices. Now, the way this table is composed actually is simple to follow. So if I look at the first row, first column, remember the true state of nature about the null is true. So what that meant for us in the case of our court system, what that meant is that the defendant is truly innocent. This person that's sitting there in the defendant's chair is innocent. The jury comes out and they reject the assumption, the hypothesis of innocence. They're going to say, no, this person is guilty. Well, if the person is truly innocent and the jury finds him guilty, well, there is a kind of an error, right, that has occurred in that decision. The correct decision was not made in that case. So this is what we're going to call a type 1 error. Okay. And if you look at the cell right next to it, or like actually go below it, same scenario. This person is truly innocent, and the jury comes out and accepts the hypothesis of innocence. So the person is innocent, the jury finds him innocent. It looks like the correct decision is made. That's why I put a check here. So everything is fine now. In this cell, the upper right cell, I have a check mark. Look what's going on here. The true state of nature about the null is false. The defendant now is truly guilty. The jury comes out and they reject the hypothesis of innocence. In other words, they find him guilty, him or her. Okay, so a guilty person was found guilty, right? A guilty person, null is false, reject the null, was found guilty. Looks like the correct decision is made, and this person is probably going to end up spending some time behind bars or whatever. Directly below that, again, we're still in this column. So remember, this person is guilty because the null is false. That person is guilty. The jury comes out and they accept the hypothesis of innocence. So they actually find him innocent of the crime that was committed. Maybe this person had a good attorney that was able to get him off the hook. It could be me. I pass a red light and I can get someone to dismiss the citation. So I still committed the crime. I did pass the red light, but somehow the court finds me innocent. Okay, so in this case, a type 2 error is committed. So anytime we do hypothesis testing, there are two types of errors that we can commit, a type 1 error and a type 2 error. Now, both errors, by the way, are important. So as far as which one is more important error, it depends on the objective of the research. In our work going forward, just so you know, our emphasis would be on a type 1 error. Section 9.7, I believe, deals with type 2 error, computations, analysis, and descriptions, and so on, but that's an optional section. We're going to skip over that one. So our focus would be primarily on a type 1 error. So here I have actually written what the type 1 error is. The type 1 error is the error of rejecting the null hypothesis when in fact it's true. See, reject the null when it's true. It flows like this on the table. First row, you hit the cell and go up. True, null. There you go. See, you reject the null when the null is true. A type 2 hypothesis, a type 2 error of a hypothesis would be the error of accepting the null when in fact the null is false. So as accepting the null hypothesis when in fact it is false. In other words, the alternative was the correct one, but we missed it. Now, the probability of each of these errors these are events. These have their own probabilities. So the probability that's associated with the type 1 error, we're going to call that alpha. And a probability associated with the type 2 error, we're going to call that beta. Okay, so those are the two probabilities. So keep in mind, alpha and beta, these are not type 1, type 2 errors. Alpha and beta are probabilities of those. So being probabilities, that means, maybe I should write that, both alpha and beta, here's alpha, here's beta, they must lie between 0 and 1 because there are probabilities. Okay. Now, this letter alpha, Greek alpha, should be familiar to you because in chapter 8 we used it. Now remember, in chapter 8 when we talked about confidence intervals, we talked about confidence level, that was 1 minus alpha. And in that chapter 8, we called alpha the uncertainty level associated with the confidence interval, right? So that's what that was. Alpha is now all of these. Alpha is probability of a type 1 error. Alpha is also called the size of the hypothesis test. And alpha is also called the stated significance level of the test. Now, the size of the test will be determined by, in the case of homework problems, the author, but usually alpha is stated or determined by the researcher. That's why it's called a stated value in here. See, it's something that's predetermined. Okay. When we put numbers to these folks, things will get more clear. Right now, it's highly conceptual, as I mentioned in the beginning of this lecture. Now, judging from the role alpha played in chapter 8, uncertainty level, in chapter 9, probability of a type 1 error, seems like both of those have negative connotations to them. So keep in mind, maybe this will help you remember the role alpha plays in our work. Alpha is a bad thing for us. And a bad thing we don't like, we want to minimize. Okay, so the typical values of alpha are 10%, 5%, 1%. Okay, and same numbers go with beta, by the way. Now, how do we actually, because remember, both kinds of errors are bad. Either an innocent person ends up going to jail, or a guilty person is set free. So both of those cases are not good. Therefore, how do we actually minimize both kinds of errors? And it turns out, because of the mathematical inverse relationship that exists between alpha and beta, that the only way that we can objectively reduce both of these errors simultaneously, meaning at the same time, is to increase or boost our sample size. That's the only remedial action we can take. So here I went ahead and wrote down what, in our court example, what a type 1 and a type 2 error would be. We already discussed it, talked about it, but that's what that is. Type 1, innocent person is found guilty, and in a type 2, a guilty person is set free. Okay. And then let's talk about statistical significance, and then we go actually look at an exercise here. So in general, anytime you hear in either research on radio or television or in your reading of literature, so on and so forth, when you hear or read the words, the results of some research were statistically significant, what that means is that someone somewhere was able to reject a null hypothesis. Anytime we reject a null hypothesis, we say that the result of research were statistically significant. Means you went through statistical procedures and you find the result to be significant. Here, significant meaning different from the null. Okay? And that's what that is. Of course, for a given alpha level. Now, in this exercise, here we have an example there. And in the exercise, there are three parts of this exercise. Part A, determine the null. Part B, determine the alternative. And in Part C, classify the hypothesis as two-tailed, left-tailed, right-tailed. Okay. Now, actually an interesting exercise this is. In this exercise that we are reading, this has to do with the early onset of dementia. So it reads, as you can read, dementia is the loss of intellectual and social abilities severe enough to interfere with judgment, behavior, and daily functioning. Alzheimer's disease is the most common type of dementia. And then there's a full citation to this research. This is an actual research that was conducted. So in this exercise, the researchers explored the experience and struggle of people diagnosed with the dementia and their families. Now here's the part that applies to what we want to do. A hypothesis test is to be performed to decide whether the mean, notice I've highlighted the keywords here for you. The mean age at diagnosis of all people with early onset of dementia is less than 55 years old. Well, the highlighted word mean tells me that we're doing this for mu. And why is it mu, not x bar, the sample mean? Because it's of all people. The mean of all people. That's what mu is. And right here it is. X is the random variable. What's x here? Those with early onset of dementia. That's what the variable is. And it actually gives us a direction here, less than 55. Now, remember I said you look for the keywords here, quote unquote, less than. Or less than is that. So right there, because this is less than, that pretty much fixates the alternative hypothesis. And there you have it. So I was able to actually write these up. In Part A, what's the statement of the null? Remember, the author in your book always takes null to be equal, always equal. And alternative, of course, we all agree that should be less than. Now, if you write the null as greater than or equal, that would be perfect also, because greater than or equal is indeed complement of less than. So that's even more accurate. But nevertheless, this is mathematically sound. It's okay. We do that. For the work we do, that's fine. And because of the alternative is less than, so this is a left tail test. If it was greater than, it would be a right tail test. If it was not equal to, it would be a two tail test. Okay? Now let's read on further. In this exercise, now a continuation of the one we just did. The exercise now reads, refer to the exercise that we just did. Okay, that would be exercise 9.8. Explain what each of the following would mean. A type 1 error, a type 2 error, and the correct decision. And then for this part that reads, now suppose that results of carrying out, we're going to actually put that on hold. Okay, so this portion of it, we actually put this on hold for now. There you go. That part we put on hold for now. Okay. So let's say for the exercise number 8, what is a type 1 error? What kind of error would that be? What is a type 2 and what are the correct decisions? So we're looking at the cells in that table that we're just looking at. Okay. So a type 1 error, remember, that's rejecting the null when in fact it's true. Now when we say reject the null, let me pause. Okay, rejecting the null here in our example, that means mu is equal to 55. So remember, you reject the null when in fact it's true. So if the mean is indeed 55, but the result of the sample lead to the conclusion that it is less than 55, that's what a type 1 error would be. What is a type 2 error? A type 2 error, remember, is accepting the null when in fact it's false. That means accepting that the mean is 55 where we should have said it's less than 55. Right? Accepting the null again here means accepting the fact that the average age at the onset is 55. But that is the wrong decision. So that means alternative would have been the correct decision. So if the mean is less than 55, but the result of the sampling fills that conclusion. And that's what that is. And in part C, the correct decision here is, well, the correct decision if the mean is 55 and the results show that, or the mean is less than 55 and the results show that. So that's what those are. Okay, those are both the correct decisions. Now in part D of the exercise, to do part D, I'm going to now read on this part. Now suppose the result of carrying out the hypothesis test led to non-rejection. So here's what I gather when I read this. So these researchers actually collected the data, and the result of the sample led to non-rejection, means they came out and they published their work, and they say we could not reject the null. That means they concurred with the null and said the average age is 55. So that's leading to non-rejection, means that. Now the problem states, classify the conclusion by error type or as a correct decision if in fact, means indeed, if indeed, in fact, the average age at diagnosis in part A, it is 55. So remember, they said the result led to non-rejection, right? When they say we could not reject, that means they are agreeing that the average is 55. And if in fact the mean is 55, well, that's the correct decision, isn't it? They didn't reject it, and it is in fact 55. So everything is good. So in part D, that would be a correct decision, right? So they did not reject the null, and if mu is 55, then this is the correct decision. Now, in part E, the last part of this exercise, again, they did not reject the null. This is what they believe in now. But in fact, it is less than, means that would be the true state of nature I talked about earlier. It's less than 55. They should have said it's less than, but they didn't because the sample did not provide support for that. So what if it was less than 55 and they by mistake said it is 55? Well, that's the very definition of a type 2 error, right? Because they did not reject the null and the truth is the alternative. So in other words, because they accepted the false null. See, that's what I have here. It seems like we accepted the null when in fact it was false. So this is the definition of a type 2 error. Okay, so there you have it. As I promised, as I mentioned in the beginning, this section was very conceptual. The future sections, don't worry, it's not going to be like that. In the future sections, we actually have now formulas that are coming up. We'll show you the steps we take in showing or proving or disproving a hypothesis. And it's not going to be so conceptual. But then we need to know these definitions nonetheless in order to be able to do the future sections. So with that, we are done with this video.